Human Movement Analysis of a Vertical Jump by Joel Gordon, 3119127. A vertical jump is the act of raising one's center of gravity as high as possible in a vertical plane purely using the muscles of the body. The vertical jump is a crucial movement in many sports. A high vertical jump contributes to successful athletic performance predominantly in sports such as basketball, AFL, netball, and volleyball. It is a fundamental task required for all humans to have coordination and synchronization of multiple joints and muscles. In the vertical jump, there are two types of jumps to propel the body's center of mass upward: a counter movement jump and a squat jump. The counter movement jump allows an initial down movement, while a squat jump starts from a squatting position. Today's analysis will be focused on the counter movement jump. The vertical jump can also be and is commonly used as a measuring tool to assess ability to display power, explosive strength, and the ability to use your strength. The counter movement jump is commonly used method in performance diagnostics to measure leg power and explosiveness. The aim of the vertical jump is to generate force to produce a maximum velocity, resulting in a maximum elevation of the body's mass, followed by a coordinated landing feet first with the body in balance. As the aim of the vertical jump is to raise the center of mass as high as possible, there are some factors to consider that affect the jump. The qualitative analysis has been used to develop a performance criterion for the vertical jump. Examining the movement allows to determine the contributing factors that may be improved to enhance overall performance. This is achieved by identifying the main factors which are the determinants of the skill and the performance in their most pure form. For example, jump height is determined by takeoff height, flight height of center of gravity, and reach height. Reach height is the term determined by body position and limb lengths, which are not determined by any other factors and therefore termed main factors. The main factors that need to be considered are initial velocity, counter movement, and flight height of center of gravity. Producing initial velocity is important, as the athlete cannot produce any more velocity once both feet have left the ground and are airborne. Increasing the initial velocity comes with developing the timing of body segments and lowering the center of mass. This can occur by recruiting the muscles of the body, including the gluteus maximus, quadriceps, gastrocnemius, and soleus complex. Working in time and allowing the muscles to have an eccentric and concentric contraction acts as an elastic band to produce more velocity. This elastic energy depends on the athlete's range of movement and hip, knee, and ankle joints. The counter movement is linked with the base of support, producing a more efficient balance and creating a more reassuring center of mass, which is lower to the ground and allowing the elastic energy to build and fire. The additional impulse from the arm swing in the vertical jump is an important base contributing to a higher vertical jump. With an increase in velocity through the recruitment of muscles and timing of body segments, plus an effective counter movement will result in an increase in height of the vertical jump. A vertical jump involves predominantly changes in potential energy and can be broken down into 4 phases: preparation phase, counter movement phase, takeoff phase, and landing phase. The first 2 phases occur while the jumper is still on the ground. The height of the jumper's center of mass is determined by what happens on the ground. I am now going to show you the video of the athlete performing a vertical jump which I am analysing today. The ideal preparation phase is a lowered body causing flexion of the hip and knees, dorsiflexion of the ankle, and hyperextension of the shoulders, while decreasing potential energy. As gravity acts upon the body, it forces it towards the ground. The eccentric contractions of the rectus femoris, gastrocnemius, and hamstring stop the body from hitting the ground, therefore producing elastic energy. The ideal setup for a vertical jump starts with a well-balanced and postural stance with feet aligned and shoulder width apart for a constant base of support. The athlete should have their back straight and head up, ready for the lowering movement. The range of motion for the athlete's knee flexion lies between 90 degrees and 120 degrees to really create sufficient elastic energy for a maximal jump. The hip flexion should also be between 90 and 120 degrees, being deep enough to allow maximization of force. Analysing the athlete's preparation phase, the initial setup for the athlete's jump, there are some positives, also some errors that have been displayed. The initial stance of the athlete is decent as the posture is correct, back straight and head up, but the athlete's feet alignment are uneven. The left foot is slightly in front of the right foot, creating an uneven balance and shifting the center of mass occurring by one leg having more load being placed upon it. The slight displacements of the feet also create an undistributed force across the mass, and as a result, less force generated as a whole. As the athlete's body lowers and the muscles have an eccentric contraction, the knee angles lie between the optimal range and the hip angle is deep enough to both allow maximization of force due to the longer time creating elastic energy. The counter movement phase. The arm swing and the squat motion is an important part of the jump as it allows the athlete to maximize height. The counter movement is linked with the timing of segments and the athlete's range of motion. The movement utilizing the stretch reflex of the muscles generate elastic energy during the eccentric contraction phase. The counter movement is accomplished by decreasing the knee and hip angles in the downward phase of the jump. The counter movement of the athlete flows, but the left foot leaves the ground during the movement, creating an unstable balance and reducing the force that can be applied through the concentric contractions of the lower muscles, potentially causing injury. The athlete also hyperextends the shoulders in a full range of motion. This range of motion could cause injury to the shoulders and have later impacts. At the takeoff phase, the net joint movements at the knee, hip, and ankles are positive as the load-carrying structures are being utilized to extend the hip, extend the knee, and plantar flex the ankle. The muscles are producing a fast conversion from eccentric to concentric contractions throughout the lower body. The takeoff phase ends when both feet lose contact with the ground. To ensure a vertical trajectory and safe jump, the landing point should be the same as the takeoff point. The takeoff of the athlete starts by the center of mass shifting forwards onto the toes, resulting in a decrease in force as the heels of the feet are lifted off the ground, creating more stress through the legs and unbalanced stance, more inclined to injury. Once left the ground, the athlete's center of gravity moves forward, affecting the optimal vertical projection and decreasing the maximal height of the jump. At the peak of the jump, the athlete's arms have not fully extended, resulting in a reduced initial velocity and maximal height. As mentioned in the counter movement stage, the arm swing is beneficial as it is timed with the body segments. The landing phase is very important as a correct landing will prevent many injuries. Optimal landing is with a stable support and wide base with feet shoulder width apart while following through with the movement, so the muscles and joints do not have excess force placed upon them and will ensure a safe landing. Also, landing in the same point as takeoff will guarantee the velocity vector is in a vertical plane, not a horizontal plane. The landing of the athlete is poor as they do not have a stable support and wide base for balance. Their feet are hip width instead of being shoulder width apart, 19 centimeters too small as seen by the diagram. The athlete's landing is very shallow as they do not absorb the force for a safe landing by following through the movement rather than stopping with rigid joints. There is a 36-degree difference between the angle of hip flexion and a 20-degree difference between the knee flexion. As the athlete's landing point and takeoff point are significantly different, resulting in a decreased maximal jump height. The areas in red, which are highlighted in the performance criterion, are the areas that need the most improvement in order to maximize jump height. The technique of the jump needs most improvement and would be most beneficial. Through the video analysis, the athlete must adjust the initial start position of the jump by aligning the feet and standing shoulder width apart. They can do so by using a line along the ground and markings and measuring shoulders to ensure proper stance. The athlete needs to work on a range of movement within knee, hip, and ankle joints. The use of stretches to the hamstrings, glutes, gastrocnemius complex, hamstrings will increase the flexibility and improve the range of movement. To ensure a vertical jump and not a forward movement, the athlete needs to take their time and do not rush through the movements, making certain they are jumping vertical, leading to an increase in jump height. There is an additional training that can be implemented to improve technique and performance. They include the use of core strength to assist further stabilization and balance, dynamic and explosive training such as box jumps and sprints to enhance lower limb power and weight training focusing on key muscle areas, including the gluteus muscles, quadriceps, hamstrings, and gastrocnemius complex. It is important to repeat the analysis process and monitor results as this will improve performance. The right use of training and development of the technique will lead to a better initial velocity and ultimately higher vertical jump.